Alright, so today what we're going to do is continue with our sine and cosine graphs, and this should be 5.2, not 5.1, but what we're going to look now is translating these graphs. So we did amplitude and period in the last lesson, which is how much we're going to make a vertical stretch or horizontal stretch. Today what we're going to look at is taking these graphs now and translating them up, down, or left and right. So you can see with this graph we've got everything going on. We got some stretches, some translations, and so on. So we'll come back to it later on. So remember from our previous lesson that so far our equation is a sine bx. So the a is our amplitude or our vertical stretch. Our b is related to our period, so that'll give us our horizontal stretch, and from that we can figure out the period of the graph, and from that we can draw our graphs. We know that a sine graph starts at the origin normally and goes like that, and we know our cosine graph starts normally at 1 and does something like that. So we have our two types of graphs. We have our basic stretches, so now today we got to figure out translations. So what changes with our equation, just like when we did our first unit, is our vertical translation typically is written as a plus d number at the end, and our horizontal translation is with our x, or with our theta in this case, and we write it as a negative because remember it's always opposite. So if it was plus 2, that means we're going 2 to the left. If it was negative 2, we're 2 to the right, and so on. So let's go through each of these, and we're going to start with D because it's the easier one. The D is going to be telling us how far we're translating up or down, but more importantly, it gives us the location of the middle of the graph. So it's our vertical translation, but we also call that the midline. So for our regular graphs, when we move it up and down, we want to figure out that midline. And the formula we can use is we can go max plus min divided by 2, or just basically figure out the average of the height. So let's go back to our title page. So we can see our max is at 3. Our minimum is at -1, so we can go 3 plus -1 divided by 2, which would be 2 divided by 2, which is 1. So that means our midline of the graph is at 1. So our D would equal 1, which means we've shifted the graph upwards 1. We did a vertical translation of 1. Okay. We can also see from this graph, from what we know before, we have an amplitude now of 2. So we've got an amplitude of 2 and a midline of 1 so far, and that's it. So the next part of the graph is figuring out the translation left or right. This one's a little bit harder, and the key thing with this one is that C value is going to give us our left or right, but in terms of a sine graph, because they repeat, sometimes we can actually get more than one right answer. So in terms of sine graphs, we call that a phase shift. So instead of a horizontal translation, it's also known as a phase shift. And what we want to do is we want to use where that sine graph should be on the midline of the graph. Because our graph gets shifted up or down, we want to basically make a new imaginary x-axis, which is at the midline, and from that we want to figure out whether it's been shifted left, right, and so on. So let's go back to the title page one again. So you can see the way I drew the midline. Here's our starting point. So we can actually see our starting point of the graph is there, but our graph is going downwards instead of upwards. So one option in this case is we can say we have an amplitude of 2. We know it's a sine graph, and we know that it's not shifted because it's starting where it belongs, so that's just that, but we know it's upside down, so that'd be a vertical flip, so we can write it as -2. We have a midline of 1, so the only thing we have left is our B number, which is based on our period. So based on this graph, if we went from start to one complete cycle, we're at 3.14 or pi, so that means our period is pi, so our B number would be 2 pi divided by pi, which is 2. So in our equation we should have -2 sine 2x plus 1. That would be the right equation. But we have a bit of a problem here, because do we know necessarily that it was a flip? The way we did this, we started it as a flip. The other option is that we could have said, well, maybe it's actually just a regular sine graph, but we've actually done a phase shift. So in that case, this point here should be shifted over. So we could write this exact same equation as 2 sine 2x. That part doesn't change. But now we've shifted the graph halfway. So instead of pi, it'd be pi by 2. We've shifted it to the right. So we would say minus pi by 2. So that's another option. So having a negative flip or going a shift of pi by 2 to the right would also be correct. Okay? Or you can see we could actually go this much distance to the left. We could go pi by 2 to the left, and that would be the same thing. So we got lots of different options to these graphs. The last one we could do is we could actually have done a cosine graph. So our cosine graph would be 2 cos 2 x plus 1. That part stays the same. But now our cosine, instead of starting here, we know it would start up at the peak. So we've actually shifted this over 45 degrees, so we could write it as x plus pi by 4, and that would give us the same graph. So the phase shift actually causes us a little bit of problems because we actually have more than one choice. So if you're given the choice, you can do whichever one you want. Otherwise, the question will sometimes tell you which way to go. So let's look at a couple examples. So here we've got our amplitude of 1. There's no number in front. We've got a b of 1 as well. So that means we have a period of 2 pi over 1, which would be 2 pi. We have a c value of pi by 2, and that's a plus. That means we're going pi by 2 to the left. And we have a d, or a midline, of 3. So from that, we should be able to figure out what our graph's going to look like. So we're going to go from 0 to 2 pi. So we're starting a normally sine graph. We're going to start at the origin and go up to 1 and down to 1. So that part's the same because our amplitude's 1. The only thing that's different is we're shifting this thing upwards to 3. So we'll do that in a minute. And our period's 2 pi, so that's our regular graph. So that's good. So the only thing that's different now is we're shifting it up to 3. So let's do that first. So that means if we take our negative 1, go up to 3, up 3, that's going to be at 2, and our positive 1 is going to go up to 4. So our graph then would be starting at the middle. It's going to start at 3, go up to 4, and down to 2, something like that. And we're going to do our phase shift now of pi by 2 to the left. So that would be, there's our pi by 2 value, but we're going to go to the left. So that means we're actually going to start this thing then there, and everything else gets shifted over. So let's kind of just draw our midline in here. That'll help. So instead of starting at 0, we're going to start there. Our first x-intercept of pi is now going to be at pi by 2. So we've got our first part of the graph would look like that. This one's going to get shifted over as well. So we know our second part's going to look something like that. Okay, let's try another one. So here we have an a of 2, so we have a 2 times vertical stretch. We have a b of 2, so that means our period is 2 pi over 2, which would be pi. And we have a c of pi by 2 to the right this time. And we have a d of 1, so we're going up 1. So when you're drawing these, it's usually a good idea, I would say, to put the midline in first. We didn't on the last one, but let's try it this time. So we have a midline of 1, so we know that our graph's going to be shifted up, so let's draw that midline at 1. We have an amplitude of 2, so that means our graph is going to, let's draw a regular graph. We'd start there, and we're going to go up 2, and then down 2, so something like that. And that would be a period of 2 pi, but we're actually shrinking this to pi, so let's look at that translation. So we'd have it go up and back down in half the distance. And our last thing is we've got pi by 2 to the right, so we're going to take this coordinate and move it over pi by 2 to the right, which would be right there. So we're actually going to start there and do our graph from there. So in this case, our graph would actually end up looking sort of upside down. So our final graph should be like that. So we're going to go downwards, up, and so on. But our midline's at 1, and that's it. Let's try another one. So this one's a cosine graph. So our A is negative 1. Our B is 1/3. So that means our period would be 2 pi divided by 1/3, which would be 6 pi. Our C is pi to the right. And our D is negative 1. So once again, let's sketch our midline in there at negative 1. Our amplitude's 1, so it's basically going to go from that up to 0 and down to negative 2. and it's a cosine graph, so normally we would start there and go downwards, something like that. But in this case, we're going a period of 6 pi, so this would be...
Mr. Sampson, please contact the office.
That would be at 2. So for 6, that means we're going to be really wide. It's going to actually go something like that. And then our last thing is we've done a shift of pi to the right. So that means instead of starting at the origin like we have it, it's going to start over here. So we'd actually get our graph going something like that. So from 0 to 2 pi, our graph would look just like that. So we wouldn't see too much of the graph. We'd only see this little section here. Okay, let's do a few going the other way where they give you the graph. These ones are nicer because you get the picture, but they're a little bit harder to figure out your numbers. So once again, we need to figure out our A, B, C, D, and then once we have that, our equation is good. So typically what I would say is start with your midline. Midline is always the easiest, and it's a good starting point. So if we look at this graph, we're going from negative 0.5 to negative 1.5. So our midline would be at negative 1. So D is negative 1. Now do your amplitude. So we're going from there up. So we're going from negative 1 to 0.5. So we'd have an amplitude of a half. And our period, let's do that one next. So our B, if you look at one complete cycle, so if we start here, we do one complete cycle, we're at 2 pi over 3. So our B would be 2 pi divided by 2 pi over 3, which would give us a 3. And our last one, our C, is our phase shift. So let's do our sine graph. And if we started here, we should be going upwards. So we can see we've actually shifted the graph over pi by 3, because that points at pi by 3. So we went pi by 3 to the right, so that should be a minus pi over 3. Now that we've got all those numbers, we can figure out our equations. We'd have y equals 1/2 sine 3 x minus pi by 3 minus 1 for our D, and we're done. The other question it says on here is write it as a cosine. So when you do a cosine graph, everything's exactly the same except our phase shift. That's the only thing we got to be careful of. So let's go back to our graph again, and if it's a cosine graph, that means our graph should start right at the peak. So our peak of the graph should be there, but it's not, it's here. So you can see we actually went pi by 6 to the left. So the only thing that would change is we'd write our phase shift as plus pi by 6 instead of negative pi by 3. And that's all for that one. So let's try a couple more. So here's another one. We want just the sine equation this time. So find your midpoint. So we'll do your A, B, C, D again. Let's start with D. So our midpoint's at 1.5, so that would be at 0.75. Okay, our amplitude goes from 0.75 to 1.5, so that's 0.75 as well. Oops, sorry, I messed that up. Let's fix this one. Our D isn't 0.75. I missed the negative part of the graph, so our D is going from 1.5 to negative 0.5. So halfway on that one would be 0.5. Right? From negative 0.5 to 0.5 is 1. From 0.5 to 1.5 is 1. So our D is a half. So now our A value goes from a half to 1.5. So that's 1. So that's good. And our B, if we look at one complete cycle, it's going from 0. If we start there, it's ending at pi. That's our one complete cycle. Or we could also go from here to here. So you can see that that works out the same. So we get pi. So our B would be 2 pi divided by pi, which will give us 2. And our C now is we want our sine graph to start right there. So where you can see we've shifted to the right. We went 1 square, which would be pi by 12. And it's to the right, so that would be negative. So our equation then is 1 sine x sine 2x, put the 2 up front in brackets, minus pi by 12 plus a half. So when you're working with these, the key thing is make sure you get that B value. Or sorry, the C value. So the C is from where it should start. So if it's a sine graph, it should start right at the midline. It actually started one spot over, so figure that out, which was pi by 12, and you're good to go. Okay, I think I got one more. Yeah, so here's another one. So sine once again, so find our midline. So we're going from negative 2 looks like 2.5 is the bottom, up to 0.5 at the top. So that gives us a distance of 3, so halfway would be 1.5. So our midline should be at negative 1.
Jennifer Littlewood to accounting, please. Jennifer Littlewood to accounting, please.
Okay, let's figure out our amplitude. So we're going from negative 1 up to 0.5, or you could go from negative 1 down to 2.5. So we get an amplitude of 1.5. Our B value, let's figure out our period. Let's start here in this case. It doesn't really matter, but we're going from here to here. So you can see we're going from negative 1/2 pi up to 3.5. So that would be a period of 4 pi. So our B would be 2 pi divided by 4 pi, which would be 1/2. And our last one, our C value, our sine graph should start at the origin. It doesn't, it starts right there. So you can see we went negative 1/2 pi to the left, so that would be positive pi by 2. And we're done. So our equation should be 1.5 sine 1/2 x plus pi over 2 minus 1. Let's try one more. So this one, they give us the equation in words, or the description in words, and we just got to figure out the equations. These ones are usually a little bit easier. So for letter A, we've got an amplitude of 2, a period of pi, so that means our B would be 2 pi divided by pi, which is 2. We have a phase shift of pi by 3 to the left, so that'll be a positive. And we have a vertical displacement of 1 down, so that means our midline would be at negative 1. So our equation is 2 sine 2 x plus pi by 3 minus 1. And for letter B, so that was letter A, for letter B we can do the same thing. We have an amplitude of 1/4, a period of 6 pi, so that means our B would be 2 pi divided by 6 pi, which will be 1/3. Our C is pi to the left, so that would be positive pi, and our D is 2 up, so that would be plus 2. So our equation should be 1/4 sine 1/3 brackets x plus pi brackets plus 2. And we're finished. So that's it for translations up and down. A little bit more complicated because of the phase shift idea, but the key to all this is get that midline in place. Once the midline's in place from the graph, then you can easily figure out your C value as well. And that's all for today.